Welcome to this explainer. We've all heard the buzzwords, right? Bitcoin, Ethereum, crypto, they're everywhere. But today, we're actually going on a deep dive into the revolutionary architecture that literally powers the whole shebang, the blockchain. It's a fundamentally new way of thinking about data, security, and trust, and we're going to break it down so it makes absolute total sense. Let's get into it.
To get us started, think about a truly massive concept. What if one single book held every single financial transaction in the entire world? Just imagine the sheer volume of data and, well, the absolute necessity for that book to be perfectly accurate. Keep that massive, universally important book in your mind because it's literally the perfect analogy for everything we're about to uncover today. So let's expand on that thought. Imagine this giant accounting book that records everything. But here's the massive twist. Imagine this book isn't locked away in a traditional bank vault. It isn't sitting on some highly guarded company server. And it definitely isn't owned by any single organization, government, or CEO. Instead, millions of people worldwide hold an absolutely identical copy of this exact same book right on their own computers. This elegantly solves what computer scientists call the double spending problem. Because if someone tries to maliciously alter a record, the rest of the network spots the discrepancy through consensus and just immediately rejects it. Believe it or not, this beautifully synchronized global accounting book, that is exactly how blockchain works.
Okay, let's dive into this, the anatomy of a blockchain. Blocks, chains, and ledgers. We've got our macro concept of the giant shared book, so now let's translate that beautiful analogy into the literal fundamental terms. A blockchain is a chain of digital blocks connected together forever, each storing mainly transaction data. The word itself is wonderfully literal, isn't it? A chain of digital blocks. Think of each block as a page in our giant book, just filling up with transaction data. Once a digital block gets completely full of that data, cryptographic math permanently and irreversibly links it to the previous one. Then, a brand new block is created to take on the next set of data. This process just continues forever, creating a secure, completely unbroken history of data.
And a ledger is an accounting book used to record transactions. Now, this grounds us right back in our initial analogy. A traditional ledger is centralized. Your bank holds the one true copy of your balance. But blockchain completely upends this with what we call a distributed ledger. This ledger is shared across thousands and thousands of computers. Everyone keeps the exact same, constantly updating version of the records. Power to the people, decentralization, and nodes. We know what the pages of our book look like, but let's shift gears and look at who is actually holding, updating, and fiercely protecting them. And this brilliantly illustrates the core philosophy of this technology, decentralization. On one side, you have the traditional bank. It relies on a central ledger, has a CEO making the rules, and it lives on a central server, which, by the way, is a massive single point of failure. On the flip side, the blockchain operates on a distributed ledger. There is absolutely zero central server, no CEO calling the shots, and no controlling company whatsoever. The power and the data are distributed uniformly across a vast network of computers. Those computers sharing the load have a specific name: nodes. Nodes are simply the computers connected to the blockchain network that store copies and verify every new transaction. They're basically the guardians of the book. They act as independent validators for every single new transaction that comes in. If a transaction is invalid or if it's outright fraudulent, this digital immune system instantly spots it and rejects it. Thousands. The real secret to its robustness is sheer scale. We aren't talking about, a dozen computers sitting in a back room somewhere. We're talking about thousands upon thousands of these node computers operating simultaneously. This creates incredible fault tolerance. If half these computers suddenly lose power or just go offline, the blockchain doesn't skip a single beat. It just continues operating seamlessly because the rest of the thousands of nodes are still there, keeping identical versions of the records running perfectly. Let's move on and see how this builds. The workforce. What do miners actually do? We have our network, but who is doing the really hard math to write new, approved pages into our giant book? Step 1. Powerful computers solve complex mathematical puzzles. Step 2. The first to solve it adds the next block. Step 3. The miner receives Bitcoin rewards and fees. So here's how this mechanism, often called proof of work, actually functions out in the wilds, particularly in the Bitcoin network. It's essentially a three-step race. First, miners use immense computing power to compete against each other, trying to solve wildly complex cryptographic puzzles. Second, the very first miner to actually solve that puzzle earns the exclusive right to add the next completely verified block of transactions to the chain.
And finally, for expending all that computational energy and securing the network, the winner gets a reward. They receive newly minted Bitcoin plus transaction fees. It's a brilliant financial incentive to keep the network running and process transactions honestly. Unbreakable security, why the system is practically impossible to hack. We've talked about the blocks, the distributed ledgers, the nodes, and the miners. Now, let's look at how all of this creates an ironclad security system.
Every block connects to the previous one, thousands of nodes maintain identical copies, and changing past records requires controlling most of the network. So, the crucial point here is that these features interlock perfectly. Because every single block is permanently linked to the previous one, and because thousands of nodes maintain totally identical copies of the entire chain, any attempt to tamper with history is glaringly obvious. To actually change a past record, a hacker would need to execute what's called a 51% attack, meaning they would have to simultaneously take over and control the majority of the thousands of nodes in the entire global network at the exact same time. The sheer computing power and coordination required to pull that off makes attacking the blockchain practically impossible.
Understanding blockchain is the first step toward understanding the future of digital finance. Which brings us to our conclusion. Blockchain is a profound innovation because it beautifully combines complete decentralization, absolute transparency, and unbreakable security all into one highly functional system. It's the underlying architecture making Bitcoin and thousands of other cryptocurrencies possible. Like the quote says, understanding it is step one toward understanding the future of digital finance. It literally changes how we establish trust in a digital world, all without ever needing a middleman.
Are you ready for the future of decentralized digital finance? That leaves us with one final incredibly exciting thought to ponder. Now that you actually understand the mechanics of this giant, globally shared, completely unhackable accounting book, what comes next? The foundation is built, the nodes are running, and the blocks are chaining together right as we speak. Thank you so much for joining me for this explainer, and keep exploring.